Hello, everyone, and welcome to SuperAnnotate's yet another webinar. I'm Dave, and I'm the project coordinator for this series of webinars. Let me introduce our speaker for today. I have the greatest pleasure to host Oscar, SuperAnnotate's head of AI solutions.
Hello, nice to be here, everyone.
Perfect. And today's topic is how to deal with dataset bias. I'm sure most of you folks know that datasets are just an integral part of contemporary learning algorithms. A lot of people in the community think of datasets as the chief reason for considerable growth in the field, not just as a source of large amounts of training data, but also as a means of measuring and comparing the performance of competing algorithms. AI systems can learn to make decisions based on the training data, which can include biased human decisions or reflect historical or social inequalities, even if sensitive variables such as gender, race, or sexual orientations are removed. Many of you, I'm sure, are familiar with the concept of biased data or garbage in, garbage out. Although bias in data is complex, throughout these years, we've seen numerous examples where leading companies stop using state-of-art algorithms in production because of their models making biased decisions, and what from a human perspective was just an extremely unethical decision making. A lot of existing human bias can be easily transferred to machines because technologies are not neutral. They are only as good or bad as the people who develop them. So we'll start off by just defining dataset bias. I mean, the word itself has at least 7 different meanings depending on the context, from the human cognitive bias to neural network activation function bias. But our main focus for today would be exploring and understanding the best practices for measuring and minimizing dataset biases with specific emphasis on human annotation bias. Well, before we dive in, just a few quick notes. We're going to record this webinar and our reps will try to send it to you within 24 hours. So expect a follow-up email with the recording. Do not hesitate to drop your questions in the Q&A section during the webinar, and we'll make sure to pause in the middle and in the end to answer them live. We typically have a lot of questions, so just in case we don't manage to answer them live, we'll make sure to send the answers over an email. I was just checking the list of attendees, and I do know that we have a lot of our clients here, but for the folks who might be new to SuperAnnotate, let me give a quick introduction. Vahan and Tigran Petrosians founded SuperAnnotate back in 2018. And through these years, we have raised $20 million from well-known institutional investors, with our latest round being the highest Series A raised in the field. We've grown into a truly global team with 100 plus ML enthusiasts from the US, Philippines, Sweden, Armenia, Ireland, and Bangladesh. CB Insights recognized us as one of the top 100 AI companies in the world, and we're the #1 platform in the data labeling category on G2. Needless to say, we're quite proud to have all these well-known thought leaders as our advisors. At SuperAnnotate, our goal is to help companies build the highest quality data sets for machine learning initiatives. We're able to do this by bringing together advanced tooling, ML and workflow automation, our curated services marketplace, and our best-in-class AI project management. Our data operations platform can help you automate labeling, enable unparalleled control of your annotation workflow, spot quality issues in your data, and integrate seamlessly into your pipeline. In SuperAnnotate's curated services marketplace, we've screened at over 400 annotation service companies around the world. And after a very strict evaluation process, we've selected only the top 35 to be in our marketplace. These professionally managed teams are all trained on our software so they can leverage the platform features. On top of all that, the AI customer success team, with maniacal attention to detail coupled with excellent DevOps expertise, can serve as the extension of your data engineering unit. And this is why we're trusted by the leading companies across industries and geographies, helping them reduce their ML cycle time by more than 80% and increase their model accuracy up to 15%. Well, with this said, let me hand this over to Oscar. Oscar, please.
Thank you, Dave. So yeah, we're gonna talk about dataset bias today. Since bias have so many different meanings, as they mentioned, I just want to start by discussing some of those here and talk about some of the differences, while we can focus on the human annotation bias at a later point. So we'll dive into like how you can measure this bias and ways to reduce it. And one of those examples are to work with a consensus, which is a way to reduce bias. And we'll look into that, and then we'll just wrap up, see what we learned today, and answer some questions after that. But let's start with what bias is. So bias can mean many things, both within machine learning or outside of machine learning. It's one of the, I guess, more confusing terms that people might mix up. To talk about this, I want to divide it into different parts. First, just talk about some concepts more related to the model side of things, like the bias variance trade-off and bias term for neural networks. Then we'll talk about some examples of dataset bias generally, and why I call them dataset sample bias, human sampling bias, and the human annotation bias. And the last one is what we will focus on during this webinar. So let's start with just some of the more model-centric bias terms. So what is bias variance trade-off? Well, it's a common concept I believe many might have heard about. It's one of the classical concepts you might talk about in an introductory or advanced machine learning course, while it might still be a difficult concept to grasp. So to give an overview, here we are talking about sort of the accuracy and generalization of your model, how well it is performing. And we can take a look at the left image to get an understanding of what bias and variance actually means. So bias in this case are the sort of average of the points. So if we have low bias, we have points that are averaging in the middle. If we have a high bias, we have points that are averaging further out from the center. So it's nothing about the actual individual points, but more about the general average that we get. With variance, though, it's about the spread of the points. So with low variance, we have very gathered predictions, while with high variance, we have spread out predictions. So they're more, they're not as accurately or consistently predicted correctly. So low bias and low variance means that we are accurate and we are very consistent in the predictions, while high variance and high bias means that we are inconsistent in the predictions and we are far off target. So you want low bias and low variance, of course, but there is usually a trade-off where if you decrease bias, you can increase variance. So you have to understand to get a good trade-off between those two, both of them to have the desired model performance. And there are many examples of why these both can occur. And if we take a look at the image to the right, we can have an understanding of a way where we can see bias occur, for example. In this case, we have a sort of quadratic points of data, while we are to the left working with a simple linear model. As we can see, the model cannot really fit to the points. So where the arrow is pointing, there is a consistent error. That can be seen as a bias. We are consistently predicting the points wrong. So we're off target, basically. While if we increase the degree of the model to get a polynomial model, we can get a curve or a model that actually fits to the data points much better. So there we will reduce bias by increasing the degree of the model, but many different things. And they are more model related. And as is the kind of bias term for neural networks that people can talk about when learning about neural networks. This is basically just a constant term that is added to the neural activation function. So it's set apart from the input that we might get to the neural network, but it's basically just a constant term that can be learned as well through the weights. So we'll not focus on these two really, we'll focusing more on the dataset and bias. And here they can differ quite a bit as well. So bias can be introduced in different ways and because of different reasons. So if we go through these one by one, what I here call dataset sample bias can be sort of the inherent biases we can find in a data set. So we can think about it as our society includes a lot of bias. And if we're going to gather a data set about humans or society, we will inadvertently get that bias in the data set as well. So we'll have some kind of model behavior if we train on this data that is not desired in our output. We want an unbiased output, but our society has introduced bias in the system or the data set, and it's thus sort of unavoidable there. So that's something we need to keep in mind and work around and work with subject matter experts to reduce. In the term of, oh, and an example here, there are many examples in the machine learning space that people might have heard about. One example here could be the case of racist hiring bots, for example. You know, they might have gathered a data set that have been biased. So there might be a bias towards a certain ethnicity, for example. So when training on this data set, you get hiring bots who think that ethnicity is a valid concern for hiring a person. And then you have a bad model which does bad predictions. So there is something you have to think about in those cases. The human sampling bias here, I would say, is more related to how you sample the data set. So it's more on the model creator. So when you're creating the data set for your model, you have to think about how the data set is sampled. We can have a very unbiased data set in general, but depending on how we sample it, we can create, or advertently or inadvertently, a biased data set. How an example of this can be made outside of the ML space is, for example, with car safety. So car safety systems was built by men with male anatomy in mind. So if you think about a crash dummy, they are looking like a man, and those are the car safety systems were built around those dummies. So how to save that specific anatomy. And that's why there is a bias today for survival rates that are higher among men than women, for example, because the creators sampled the sort of data set very badly. And that can, of course, be transferred to machine learning as well. And those are two things here on the sort of gathering part of the data set. What, you know, included in our name, it's SuperAnnotate. So we are very much focused on the annotation part of the data sets. And that's why we'll focus a bit more on the human annotation bias in this webinar. And this is all about the human role in the annotation process and where that can introduce bias. Since we basically need annotation for most supervised machine learning projects today, we need humans in the loop to do annotation of the data sets. And where there's a human, there might be bias introduced. It can come from many, many different sources. They can stem from things like the interpretations of the instruction, which is a very large source for this potential bias. If there is a lot of room for interpretations within how you're going to do the annotation, people are going to interpret it differently, and then they're going to do the annotations differently. That will introduce bias based on their own perception of what is correct. And you might have a data set that either contradicts itself or is skewed towards something that you do not want to have in your final model performance. But there can be other things, like there is a bias towards annotation placed later in the day when people are tired, and that can also be a cause of concern, of course. This can specifically be a problem when outsourcing and scaling. So when you're working with an outsourced workforce, you're handing off more control to another part, and you'll have them do the labeling. This is a necessity for all large-scale projects, I would say. And outsourcing is one of the best options out there, but there are things that you need to keep in mind when doing that. We had another webinar about it, which sort of falls into this as well. But it's also something when you're thinking about scaling, because when scaling, you're including more and more people in the annotation process. And when we include more people, we'll inadvertently have more people that can introduce their own bias. So these are some key things to think about when thinking about the annotation process. But why do we care? All right, like, can't we not just think about this as the natural state of things? Like, this is how it's supposed to be, with different people interpreting it in different ways. Well, in many cases, you know, bias will create worse data for you. It can contradict, it can be different than what you aimed at having. And with better data, you would need less data to train your models. That's, you know, the core of data-centric AI. We need to think about the data we are creating and working with. So it will both save time and money to really consider and think about bias. It can also cause large issues in performance. Not only can similar samples contradict each other when annotations are doing things, so models won't converge, there might also be a general bias among the annotator who is not desired in terms of output. You know, you are imagining one output, but the annotation is being done in a totally different space. That means that the annotation and the models will be wrong, because the annotations should reflect the perfect model performance. And if that is not correct, you know, you will have the annotation, annotations will be the final model performance in the end. So we need to make sure that that is correct. It is also one thing that is very difficult to change afterwards. With, you know, if you want to change your model, it's more or less easy to try another one, train it, and test it. But with the annotations, you would have to revise the whole data set, you know, go through the whole data set point by point and change or review all of them to make sure there is no bias. So that can be both timely and costly. So the three parts that we mentioned beforehand, like the gathering part with the dataset sample and human sampling bias, this annotation part and the modeling part, all of these can introduce bias and they are important. But the focus here will be a bit of on the annotation part. And I think we'll stop here for now. I would like to see if there are any questions.
Oscar, I think I see one question here. Let me read this one out loud. Does it matter what type of a model or algorithm I'm using? Will I always be exposed to bias? What do you think?
That's a good point. So, you know, as we saw with the linear models there, basically any model can have a bias, but it can come from different directions. You know, you can have a fully featured engineered model, but it will definitely have bias made from the person who created the model. So it doesn't have even to be machine learning, you can still have bias there. The dataset related biases terms will always come into play with machine learning models, because you always need some dataset to train on. And it might be that the model will be biased because we have some skewed dataset, or there might just be bias in the dataset itself that will cause some problems for the convergence of the models. So it's always something that you have to think about. It's sort of unavoidable. We can only try to minimize it.
Awesome. Thank you, Oscar. I see there's another question here. Can your platform, assuming SuperAnnotate's platform, also help with sampling dataset bias?
Yeah, so that will not be the focus of this webinar as we talked about, but it's definitely something that can be worked with inside of the platform as well. Analyzing the kind of sampling bias is sort of like doing the annotation process as well. Like the annotation process is all about understanding the data and placing the annotations. The sampling itself will also be about analyzing the data without placing the annotations. So the platform do support a lot of things to review the data as well. It can either be through a just visual process by the machine learning team, or it could also be, you know, done with a workforce to analyze it more thoroughly. But it's definitely something that can be worked on the platform itself, though our name suggests we're more focused on the annotation part.
Awesome.
All right.
I think this was it for now. Cool.
Great. Perfect. Thank you, Dave. In that case, we'll move forward with the other part of the webinar so far. So now we know a little bit about different terms of bias, why we should care, where it can be introduced. The thing that we need to understand now is how can we measure this? Like, how can we find out when we do have a biased annotation process? So the metrics that can be used here will differ a lot. For example, working with classification, we can have this kind of accuracy understanding of if things are correct or not. If we are working with location-based annotation like bounding boxes or polygons, it's much more about, say, overlap, intersection over union to understand if someone is doing something else, but it goes beyond that with measuring bias, I believe. And I think the metrics will differ a lot because they will be so dependent on what you're trying to look at. I'll show a couple of examples here of different things that can be tracked, different metrics we can use to try to find out if there is bias. In general, I think it's only fantasy that sets the limits, but some key things to keep in mind when measuring bias is to track the annotation activity per user. And rather not only on a user basis, but a time-stamped basis as well. Because what we really need to have is a data set that includes the annotation, but for every annotation, we also need who made these annotations, and for example, when it was made. All of these things will help us understand the source or the location of the bias. So with this, we can try to understand it more thoroughly. With the right format and platform, we can have a more thorough understanding of where annotations are coming from and analyze if there's any bias from those specific sources. And then we can find outliers and try to understand it more thoroughly. So some examples here is that we can try to understand the type or the class that annotators are placing, for example. This is a graph where on the x-axis we have different annotators who have placed annotations. And on the y-axis we have the percentage of annotations that they place for this specific class. For example, we see a bar in the middle, which is around 0.5. That means that this specific annotator placed this specific class 50% of the time, like 50% of their annotations were of this specific class. What we can try to find here is if there are any outliers, someone who is preferring this specific class or some other class more than others. Do we have a class bias? Does someone think that every four-wheeled vehicle is a car, while it might be a truck or a bus instead? And if we would have a perfectly distributed data set with samples being distributed evenly with everyone, this should be a even or a evenly distributed curve or graph. We don't. That's the key thing here. So this graph in and of itself would not tell us directly that any person here has a huge bias towards something, but it can give indications. It can give indications that we might need to investigate further or include something else in our metric that we have here. We might want to dive into the performance of the annotator that places this 50% of the time and evaluate to see if there is any cause for concern in the annotations they are placing. Similarly here, we have a class correlation matrix. We can see Rick and Jen placing annotations, and the matrices here show the correlation of different classes in the same image. So we can measure how many times the bike and the car both appears in the same image. So if we take a look at Rick, we can see that he's placing the bike class and the car class around 35% of the time in the same image. If we take a look at the same number for Jen, that is only 2.4%. This is a huge difference, and it can also raise some red flags. Why is there such a big difference while the other metrics are kind of alike? Does one of these persons have a bias or tendency towards placing these classes more commonly together? So if I would have seen this, I might have wanted to investigate the annotations done by Rick and Jen to understand if any one of them is wrong or if there is some other explanation behind this. And the last example here is a size example. So we have 3 annotators, 1, 2, 3, blue, pink, and green. And on the y-axis, we have the area of the instances they have been placing. So I think this is a instance segmentation data set, so with polygons, and we will just see the area of the polygons that they have annotated on the images. And as we can directly see that with annotator number 2, there are 2 cases which are far off the other annotations that have been placed. There is a shift in the distribution there, and these might be outliers in and of themselves. So we might want to understand just these 2 data points. Is there something strange here, or is it legit? While we can also see the tendencies with the box plots for each annotator. We can, for example, see that the blue annotator, annotator number 1, has a more gathered, like they have a smaller spread in the size they are placing, and it's generally a bit smaller than the other annotators. Is this something that is a bias for this person? Are they generally placing smaller annotations that are more similarly sized? Or is it because of the data that they got? It was just a reflection of that. So these will also not give a full answer, but give some cause for investigation. But then the question becomes like, how do we investigate this? What we would need to do is understand the annotation placed by these people, but we would not want to go through all of their annotations to see what might be the cause of this. So I'm going to switch from the slides here and go to the SuperAnnotate platform. And in our platform here, I am working in a team and a project which we used in a previous webinar. So if you want to check out our webinar Active Learning, you can do that. But basically what we have is a data set, and it's for object detection. And I got some help from 4 of my wonderful colleagues, Sally-Ann, Luke, Jeff, and Matthias, to do some labeling here. So they have been labeling some images with bounding boxes, and this will enable us to draw some conclusions or try to understand more what might be the actual annotations placed here, or what we can try to understand of the annotations they have placed. And another key important thing here would be the dataset versions. So in our platform, you can create a snapshot of the dataset, so you can version your dataset. And this not only gives you the ability to benchmark models against the same dataset and go back and revert if anything is wrong, but it also gives you the ability to review a dataset as it is in its finished state. So here we can calculate our metrics on the latest version of the dataset, and then we will review that specific part of the dataset and not really draw inconclusive conclusions or wrong conclusions, because we're looking at an updated dataset. But we can do the calculations on the version number 3 here, and when we go into it, we'll be brought to an exploration view of this exact dataset. So here we can really review the dataset on a qualitative basis to try to understand a little bit more about it in general. So we can decrease the column view so we see the images more clearly. We can even include classes here if we want to know more about it, or remove some specific classes if we don't want to see them in the images. But the key thing here that we can do now that we have some insights from the metrics is to try to query or search the dataset. So for example, I might want to take a look at some of the images or instances created by my colleague Kev. And then I can search my instances and select who they were created by. I can do other things here as well, like when they were created or any other attribute that is part of the data that we save. But if I search for a specific person, I can see the instances that he has created. And from this, I can try to draw some conclusion if the metrics I saw when I looked at my bias scores were accurate or not. I might see that, hey, all of these are good. There is nothing wrong with annotations that he placed. The actual metric that we saw might have been pointing to something else. And I can do that for my other colleagues as well to see if there's anything else that might be a cause for concern, for example. So what this enables you to do is further investigate a potential cause or bias and understanding it on a very qualitative basis to see if you need to take any action towards a specific annotator or anything else in the annotation process. Great. But that's all about combating bias once we see it, or once we have an understanding of the metrics there. But there are also ways that we need to reduce the bias before that. We need to have things in place to reduce the bias directly. And some of the key things that we've been talking about earlier as well is, for example, detailed instructions. Recommendations here are to give instructions that are detailed, leave less room for interpretation, and have a lot of examples. So if the instructions are detailed, if there are a lot of examples so people really know what they should do, there will be less room for interpretations and people will follow it more narrowly in that case. Another thing is to have multi-level QA. So as we can see on the bottom here, we have a our quality assurance pipeline basically. So we enable more people to take a look at the same data point to ensure that there is no bias created at any point. As we can see here, we have annotators who are placing the first annotations. When they're done, they are sending it to the next step, which is an independent person, the QA, who can review the data. They can give feedback to the annotator, return it, or change it to make sure that it's correct according to the instructions, and there is no bias introduced by the annotator. We can even have a second level of QA by the admin, who can either review every data point or just a few here and there to see overarching trends. There can be more feedback introduced, and you can have it reviewed again to be correctly made. This ties into the continuous improvement, where we see the annotation process improving over time because we are inferring feedback and instructions over time when we are reviewing new parts of the data set. And these are things that are usually unavoidable. We usually find new things all the time when annotating a data set. It's really the best way to review it. So having continuous improvement is important to not really have a drift in annotation or sorry, or mistakes being made. All right, sorry about that. Another thing that is a common way to reduce bias is consensus. It's a common tactic. What we have here is multiple people working on the same data point, not in a consecutive fashion, but independently. So multiple people place annotations on the same data point, and then we can have more of an averaged opinion. It will reduce bias, but it will also increase work because we have more people working on the same data point for less amount of data, so to say. This is an example of using our SDK to calculate some consensus for different annotators. So as we can see here, we have different annotators on the x-axis, and on the y-axis, we have a consensus score. The consensus score will relate how well the annotators are approving or having consensus with each other. So as we can see on the red and black annotator here, they have 1 point each that has a score of 0, which means that for this annotation, they did not agree with anyone else. And this can, of course, be some cause for concern as a measuring tactic to see if people are not agreeing with each other. So the box plots themselves here will instead also show a spread of the disagreement that they might have internally to see if there's any case where we need to have some involvement. That's a way to measure it, but we can also implement it in a workflow fashion. And what we can do here is have a case in this example with classifying an image. So we can have multiple people classifying the same image independently, and then we will draw some conclusion in the end. We can, for example, have a majority vote. In this case, 2 out of 3 people gave the same class, and they will accept that class as the final output. We can do this with different metrics. We can have another case where we only approve data points where everyone is agreeing, for example. And this is a very common tactic that I used as an implemented workflow for annotation. Consensus has its limitations though. For example, it's good for some cases like classification because we can define different things and we can make sure that the final output is just automatically giving a good output. We see it a lot in image classification and NLP for things like text analysis or sentiment analysis, for example. It is, however, more difficult for some other cases like object detection or instance segmentation. It's mainly because we have so many more multiple factors coming into play, like location, class, shape. It's difficult to get an unbiased metric to give a score of the bias here. So in those cases, multi-level QA is usually better to have an unbiased output. Super. So that's all for the webinar here. So to wrap up, we gave some examples of different terms of bias, but one thing that is in conclusion is that bias is unavoidable. It can be detected and can be reduced. Like we can measure it and we can implement things to reduce it, but you need good practices and good workflows, as well as good formats and platforms to have a good way to combat the bias that you might find. And in terms of this, we at SuperAnnotate see it a lot with our clients all the time, and we have to help our clients work with this to try to avoid it. So we built our software and platform around ways to reduce bias natively, but also find and detect it once it is happening. And we are working with different workflows and set up with all of our service clients to have a good way to have unbiased data sets that give good model performance. And yeah, thank you so much for everything.
Awesome. Thanks a lot, Oscar. Everyone, this was the end of the formal part of our webinar. As promised, we'll be doing a Q&A, so do not hesitate to drop your questions. In the meantime, with greatest excitement, I want to announce the launch of CV Automated Pipelines webinar series with our grand opening Epoch 1 on March 16th. In this 6-epoch webinar series, we'll talk about ways to automate the data annotation process for computer vision pipelines. We'll start with some basics and some of the most straightforward ways, and throughout the series, we'll explore some more advanced techniques and automation suites. Hang tight on this one. Soon we'll have the official announcement on our website. Oscar, I'll go ahead and stop the recording so we can dive into the Q&A. Thank you, everyone.